We will be looking at 6A from the Unit 3 and 4 Methods textbook of Cambridge. This is literally a quick revision of what you've already learnt in Unit 1 and 2. We will be looking at learning to measure angles in degrees and radians. So we know in terms of how many degrees we have in a circle, it's 360. When we're thinking about radius, we are looking at the circumference of a circle. So we know with circumference, it is 2 pi r. That is for a unit circle. So that's where, if we are going, our radius is 1, then it just ends up being 2 pi. So this is what the radius is of a full circle. So we use this as a relationship. So we can see here that pi is equal to 180, and that's the benchmark that we are going to use. We can see here that 90 is pi over 2, and we can see that 2 pi is one whole here, and 2 pi here is 0, or 360. And then we've got here 3 pi over 2, which is 270 degrees. So based on this relationship that 180 degrees equals pi, whenever we are converting to pi, we are wanting it to get rid of the 180 or the degrees and put a pi in there. So that's why, because we are converting to radians and 180 equals pi, we're just going to go pi over 180, and that cancels out the 180 and makes it pi. So if I had 270 degrees, I'll just put 270 in here and times it by pi over 180. Likewise, by going the opposite way, we just need to have that flipped. So that means instead of saying pi over 180, we're wanting to cancel out the pi's. So that means pi will be on the bottom. And we're timesing the radius by 180 over pi. For an example, if I've got pi over 2, we can see that if I times it by 180 over pi, the pi's are cancelled out and I'm left with 180 divided by 2 is 90. So we're always going back to this relationship that we can see with a unit circle. Let's look at some examples. If I've got 4 pi over 3 as radians and I'm wanting to convert it to degrees, I need to get rid of the pi, so pi will be on the bottom, and I'm timesing then by 180 over pi. The pi's will cancel out, and 180 over 3, I can divide them both by 3, and I get 60 and 1. This makes it easy. It's just 4 times 60 is 240 degrees. Likewise, if I've got 1.2 pi, I know it's going to be more than 180 degrees. But again, I want to cancel out my pi, so I have it underneath. I'm timesing by 180 over pi. The pi's cancel out, and I'm left with 1.2 times 180, which gives me 216 degrees. Then I've got 10 pi over 7. Again, if I want to get rid of the pi, so I'll times it by 180 over pi to convert to degrees. I cancel out the pi's, and then I've got 10 over 7 times 180, which is 1,800 divided by 7, which is 257.14 degrees. If we're doing it the opposite way, and we are converting the following to radians, that means we're wanting to put pi in there, so we'll be timesing it by pi over 180. And that gives me 300 pi over 180. I can simplify it by cancelling out a 0, 30 pi over 18, which is 5 pi over 3. Likewise, the next part. If I've got 15 degrees, the first thing I'm going to do again to get it into radians, I must times by pi over 180. I put the 15 up the top next to pi, and then I can simplify. How many 15s are in 180? 12, so it'll be pi over 12. I'll be doing the same thing with this degrees. I want pi in my answer when having radians, so I times by pi over 180. I can simplify by putting 201 in the numerator, and then that's the simplest form I can write it in.